Our topic is democratizing tools and frameworks for data platform. When we talk about tools, what word strikes in your mind? What is a tool? What do you guys think? Have you used all tools in some shape or form? Name me some tools. Okay. Anything else? Hmm? Title. Anything else? Tool. Guys, we use so many tools. Absolutely correct, sir. Tool can be anything. So give you some background. The word tool was formed back in 1820, right? I mean, and was thinking tool. The life is run by tool. Can you think about making a furniture without a tool or bicycle without a tool? Totally broken, right? You have a nightmare. Do you all agree? Now, think about running a data platform. Can we run without tools? What will happen? Broken data, right? So today, our topic is mostly getting about tools and frameworks, right? We have speakers. Our first line of speakers are from Intuit, and I'd like to invite Anil Bacho, Jack, and Shashan to talk about the QuickETL framework. We can be louder, man. Let's give a round of applause.
Hi all, this is Anil and Sojan with me and Tak. So we are going to talk about QuickETL, so which is a config-driven ETL framework, which is Spark based. So before we start further on that, like just how many of you are familiar with the ETL development or general ETL terms? That's great. So how many of you are familiar with the Spark and a data lake? Yeah. So just to scope it out, like what is this framework for? So we are going to cover like what is the background of it, everything. But at Intuit, we process the data on the data lake using Hive, Spark, as well as MPP like systems like Vertica. So this tool is designed, this framework is designed for the ETL processing on the data lake. So before we start covering like what exactly it is, so we are going to start with the background and then introduction to the QuickETL, and like just like a quick start with the sample examples, and what are the features or capabilities, then demo and roadmap. So this is our agenda. So before we go further, let's see like if I, in general, if I want to develop any ETL like Hive SQL or Spark SQL, this is a sample ETL like where we have some set of CTAS statements. We are creating a temp table and reusing it in the next one, and we recreating. What exactly a problem, like if we want to do in the production environments, if we want to develop these ETLs, what kind of issues with this just like set of SQLs? So how can I group these SQLs logically? Let's assume that I would like to load my data and I would like to filter my data. Is there any way I can logically group these SQLs and also I can monitor them logically? So definitely as a framework, we need where I can define my set of queries in a logical way and I can monitor them in a logical way. That is very important for us. And once I define my ETL definition, how can I test this SQL in UAT, in prod, or in my local, right? The biggest problem here is like once I define this, it is using the prod schema and prod table name and the paths of S3, it is using lots of hard-coded values. So if I want to test locally or in a UAT environment or in a prod environment, what is going to change? The scope of a data set, right? A table or a schema, right? Now we need some framework where I can define these ETLs and where I can execute in any environment at runtime. It should decide, okay, what are the parameters it need to use it. So as a framework, we very much need it. And how can I set an expectation? Like this is the SQL I'm running. Before even executing, I would like to see I'm using the, let's assume that I'm using some table app connections history temp2. And if it doesn't have some X number of records, I should break it immediately, right? Or like after processing the ETL transformation, I would like to check something like circuit breakers or validations or expectations. How can I set it? Is there any framework which can give to me? And one more biggest problem here is when I write this ETL and try to execute it, and it takes like 4 hours, 5 hours. If you go to the Spark SQL, like Spark UA, etc., you cannot correlate what query is executing, which query took what time, right? So definitely these are the really problematic for troubleshooting or like maintaining your ETLs. Apart from that, we also like listen that we have tens or like a number of ETLs defined, but you might have some common properties. Let's assume that I'm using Spark, and where I know that like executor memory, I need to set default and default number of partitions, right? So how can I set these defaults across the ETLs, common properties? So the framework should support this feature. Apart from that, few of the examples we will give. Suddenly you see some issue in the data lake and you would like to fix them across the pipelines, right? So one of the example here is, in our case, we will use different execution engines for the processing like Hive, Spark, Redshift, Athena, many, Presto, all those we will use. But there is some discrepancies, like if you write any data set through the Spark, that may not be able to read by Hive. In the one of the example where we face this issue is, like if you use any latest Spark version, it generates the decimals as like int format, whereas Hive only understands in a like a byte array format, right? So now once you identify, I would like to fix across all the ETL pipelines. How can I take it, right? So the second one more issue, we have seen like approximately 1800 tables impacted by this layout. Let's assume that in under data lake, if you have a table with the underscore 2 or some other subdirectory, Hive can understand, but Spark silently give you the 0 results. If you use this table in a join, you will get a 0 results. Once you identify, I would like to fix across all the pipelines using, like you can see, some common properties. So once in a production environment, definitely you need a framework to develop the ETLs and to fix them across all the common properties across the ETL pipelines, etc. So that's where QuickETL comes into the picture. And Sujan is going to cover what exactly it is, what is the definition of it. Yeah.
Thank you, Anil. So Anil covered the background behind this QuickETL. What are the issues with the classical SQL-based ETL model? Now let us look at how these problems are solved in QuickETL. We will go over the capabilities. We are not, in the interest of time, we are not going over all the capabilities. We will take a subset of the capabilities. And as we walk over the examples, I will explain the capabilities one by one. In general, this is a simple example of ETL pipeline definition. It has two parts. One is the pipeline definition section, and the second part is the step section. Now, let's take a simple example of a classical ETL. We want to load the data from different sources, probably NS3, Hive, and we want to do some transformation on that. Probably we want to do some standardization, filtering, and so on. Then the final output we want to store in some data store. This is a classical ETL process, right? QuickETL helps to define in the same semantics as your thought process, natural thought process is proceeding. So we have the concept of steps in which you can group all the related operations together. In this particular example, let's take a deep dive on a loader step. Let's take two examples. We have two information. We want to load two data from two different sources. Say data one from an S3 location and data 2 from Hive tables. Now, the pipeline framework, the QuickETL framework helps to logically group these operations as a single step and view it as a cohesive unit. So, few important information here. I'm not going through all the individual constructs here. Let me just go through some of the important points which may be interested in the subsequent slides. So in the first one, what essentially we are doing is we read an S3 location and we store that value in a temp table in Spark. In the second one, we are reading two Hive tables, join them through Spark SQL and store the information into an S3 location, also register in Spark temp table. We have few execution controls here. As you can see here, there is a caching capability in Spark which can be controlled directly in this metadata section. So here you are seeing this data loading as a cohesive unit. All the controls required for the data loading is grouped as a single unit, and you can control it as a single unit. Now let's go further. Now we loaded the data. We want to apply some validation on the data, and we want to proceed the pipeline only if the validation is satisfied. That's what Anil mentioned about the circuit breaking capability. So here I am putting a simple validation. In this particular example, I am reading email and I am taking a distinct count of that. My validation is that if the count is not 2000, don't proceed the pipeline. So this is the capability that is available in QuickETL so that you can control the execution of your pipeline. Now we have a pipeline definition. We saw the basic semantics of that. Now let's talk about how do we execute or how do we enable this pipeline to be executed on different environments. So the first part is we have to parameterize certain information in order to execute on different environments. For example, in prod environment, we have one S3 location, and in pre-prod environment, we have another S3 location. We may have schema 1 in prod environment, we may have schema 2 in pre-prod environment. So we can parameterize all these things. Here we are parameterizing the S3 location of reading the data and S3 location of writing the data. Now let's see how do we achieve this. We use typesafe as the configuration resolving mechanism. We use the built-in capability provided by the typesafe to hierarchically resolve it. So this is a simple hierarchical view about the configuration. Let's look at this hierarchy in 3 levels. So we have the pipeline definition at the bottom level. So here you will define all your steps, the logical steps required to perform your pipeline. Now we saw few S3 locations which has to be passed as a parameter to the pipeline, which varies from environment to environment. So they are environment specific parameters. So that goes one level above the pipeline definition. Then there are few parameters which are agnostic of all the environments. That goes one step above that. So we can go further up. For the simplicity's sake, we have limited to 3 levels. Now, at runtime, QuickETL identifies the environment and resolve this dependency accordingly. So this is one simple example. So at the base level, we define certain variables, and the environment config is included here, and the pipeline level, we are including this corresponding environment file. So this is how we are stitching the 3-level hierarchy into a single output at the end. So now let's see how the testing is achieved in QuickETL. Anil will explain the details.
Thanks, Sujan. So I know it's overwhelming with the configs, but this is a config driven. We cannot skip that config saying like everything is a config here. So as a ETL developer, so mostly you will define just whether you are implementing a ETL in a Python or like a Scala or Java, you no need to bother about it, right? Once you understand these definitions, they are very powerful. Like as of now, we have seen like how exactly we can, once you define a pipeline config, how we can execute them in different environments. At runtime, it can resolve all together, right? Now let's see that configs in action in testing, right? So we mentioned like how can I test in different environments? As you see, like once I write the SQL steps, it has some data sets like tables and schemas, etc., right? How can I scope them in different environments? If I'm running in UAT, then I might need to use a UAT schema. If I'm running in the like a production, then I might need to use in a production schema, right? So that's why in our case at Intuit, like with the QuickETL, we don't hard code like any schema names or table names. We will use the variables here, right? Now, when we execute it, like if you execute in a UAT environment mode, this will get resolved into the UAT schema, etc. So that's how you can achieve many things. Now you might ask one question. In general, in the production development, right, you have proper unit testing, regression testing, etc. But whereas in the data, like why we don't follow that, right? Like these numbers are very critical, right? How can I follow the regression test, right? So now how can I, this schema is we have seen, like, but how can I test this in a locally, or how can I test my pipeline through the Jenkins, like as a regression test, right? So the problem here is in a local machine, I cannot connect to the schema of the like production or UAT, etc. So I can scope out the table using something advanced feature called overridable configs. What exactly it provides it is, like let's assume that I have a test companies. There's a companies table, but I would like to test with the test companies, right? So what it provides you that is I can scope out this table called companies with some S3 path or local path. That can be achieved using overridable configs, and this is very much useful for us. And using this local testing, once you define a pipeline, you can just use that for the local testing as well as Jenkins for the regression testing. This is becoming very helpful for us. And as we mentioned, like unit testing, so this is very simple. Even for the ETLs, you can come up with the test coverage, right? Like, so I have a definition called pipeline here, and whatever the tables it is using, I can use the files or I can generate some using utilities, and I will execute in in-memory Spark context, and I can assert like each data frame level or table level whether my expectations are matching or not. So that's how we are able to achieve like local testing, etc. But what exactly it is happening? As of now, we have seen everything is a config, right? But how exactly these configs are constructed backend, right? This is like our architecture. So as a user, you have pipeline definitions you will maintain, which is a configuration. In the framework, we have a pipeline runner, which as a Spark submit, you need to use that pipeline runner, which takes your config and orchestrates all the configs at runtime. Let's assume that I will use a prod environment, then pipeline, and it will orchestrate all the variables of the prod and the base confs, etc. So if you see here, there is abstract pipeline step. Using that, this framework also provides you what are the common steps, like reading from S3, writing to S3, right? And also like standardizers, like email standardizer, phone standardizer, etc. And graph loader, Elasticsearch loader. So these are the common steps we already implemented. But as a user, you can still extend this pipeline step to the custom, and where you can make use of many other custom steps, you can write it. One of the biggest advantage, one more feature is instrumentation. At query level, by default, this will instrument at step level, logical step level, query level. Instrumentation is taken care by this framework. Also, it has lifecycle means like listener, like a Spark listener, we will also provide as part of the framework, so that at job level, even step level, implicitly you will get all the metrics. So at backend, like once you run this pipeline with the configs, it will orchestrate as a DAG, like a step 1, step 2, and inside the step, like multiple like inputs are there. Then we have orders. You can take like parallelly, you can execute it. So it almost like runs as a topological sort on the driver. So that's how internally it will execute this. And now we are going to see, TAC is going to show us the demo, how exactly this works.
Yeah, so I'm going to show you how to run the pipeline and how to monitor the progress. So here I have the very simple pipeline, which is named sample ETL pipeline, which consists of the 3 steps. Right? So each step does the very similar things. First, it does the drop table, and it runs the select query, and it loads the data into some table. And step 2, it runs the select query again using that table from the step 1, and it loads the data into another table. And finally, at the step 3, it uses the table from the step 2 and loads the data into the final table. So let's see how it does it.
Yeah, we could not see anything.
So I I already logged into the EC2 instance, which connect.
The text document that you were just showing.
Yes.
For the steps.
Yes. Oh, sorry. Okay, so here we do have the pipeline name called sample ETL pipeline, which define the 3-step. And the detailed definition is followed by the within these steps, right? And it basically does the drop table and then select query and register into the table. So I already log into the EC2 instance, which connects to the Spark cluster. So I already prepared this command, Spark submit. So this Spark submit command takes the basically pass to the pipeline configuration, which is sampleetl.conf. And one thing I wanted to know is that it's passing the environment deb, right? So all the variable in the configuration get resolved to the values which is specified to the dev environment. So here, when I
They're not in EC2. Yeah.
So I have to log back into the instance again. Yeah, got it. I have to kill this. I have to do the SSH tunnel. So here. Okay, so this is the tab that I'm supposed to run the command. So this command takes the pass to the configuration file, and then it's taking the environment deb, right? So when I run it, so one thing this framework does is it's emitting the bunch of the key value pair. For example, this is the application ID, which is now because the application is still being warmed up. But once the application is ready to run it, it captures the application ID as well as like pipeline name. So one way to monitor is keep watching this log, right? But sometimes logs get too verbose, right? So another way to monitor that progress is to go to the Spark UI. So we can go to the Spark UI through the Resource Manager UI here. You can see all the Yarn application is running. So you find the one Yarn application named after our pipeline name, sample ETL pipeline. So when you click this application, and then click this link, which takes you to the Spark UI. So here, you can see the pipeline progress. So pipeline is broke down to the each step. Step 1, step 2. So each step is corresponding to the one Spark job. So this is actually a nice feature because the multiple inputs, multiple sub-step is logically grouped into the one step, which is corresponding to Spark job. So if anything happens in the pipeline, user can come to here and they easily identify where the actual issue is in the configuration. So I'm going back to the console output. So as well as the this framework is emitting key value pair of the application ID pipeline. Also, it's emitting the execution stats at that pipeline level, at the step level, even at the query level too. Right? So you see here is the metric, right? So this key value pair can be consumed by your choice of the dashboard application. In our case, we are using the Splunk. So I'm going to show you what the dashboard look like in our Splunk. So this is our Splunk, and then one of the dashboard is basically showing the execution stats at the pipeline level over the period of time, right? So here we are showing at the pipeline level, but since we are collecting execution stats at the step level or even at the query level too, so you can actually create another dashboard at the more granular level as well. And then another dashboard that we have here is basically the history of the execution results over the time, right? So basically, what I just show you is that this framework is basically emitting the key value pair, which can be consumed by the user's choice of the dashboard application, and then they can create their own customized dashboard, which increase their monitoring experience. Now Anil is going to show the roadmap.
Isn't it pretty cool? Like, can you imagine, like, without this kind of framework, once you write some set of SQLs, if you go to that like Spark UI, you cannot correlate like which query is running, how much time each query is running. Now, logically, you can, whatever you define, you can see in the web UI, right? How much it is helpful, like you define and you're using the pipelines, and also troubleshooting will become very easy for you, right? As well as like monitoring of the pipelines is very easy, and at query level also it is giving all the implicit instrumentation to you. So this framework is adopted by various teams in Intuit, and it is really helpful for the UAT testing and coming up with a very good regression test, etc. So what is our roadmap on this framework? Like, we are, as you know, that Delta Lake, how many of you knows the Delta Lake? Yeah, so Delta Lake is like recently open sourced, which also provides you like ACID transactions and also upserts on the data lake. So as every company is working on GDPR and CGPI, that is very important. Like if you want to delete a particular record or like update a particular record, so we need this feature ACID transactions. So we are going to integrate our framework with the Delta Lake, as well as another one is auto conversion of high SQLs. So let's assume that most of your workloads are in Hive. How can I onboard into this config based, right? So once you provide any Hive SQL or Spark SQL, we are coming up with a feature which automatically converts into these configs. Once it is configs are converted, like you can use all the features of like instrumentation, environments, etc., unit testing all together. The other one is checkpointing. Like in general, any frameworks, let's assume that some of the ETLs runs like 8 hours, 4 hours, right? Suddenly, if it fails at the last step, last SQL, again, you need to rerun everything, right? Now, because this is totally config driven, easily we can come up with the checkpointing logic, right? And one more biggest advantage of this is like when you go to the cloud, you have multiple processing units. All of them are syncing with the same Hive metastore. In earlier case, you are creating lots of temp tables, right? If the same temp table name is used by another ETL, what happens, right? So that's why here you are not creating anything on the Hive metastore. It's only in the context of that execution, right? These are the really very interesting features, and we are really like helping a lot for our general day-to-day stuff. Like that is what the QuickETL. And any questions?
When are you open sourcing?
Thanks. Like we are just planning, not yet decided on this, but definitely like as of now, internally, we first initially this is created for the Spark, but now it is also lots of features of the manage table. Hive properties also like Hive features also inbuilt into this framework. Now we are testing across our analyst community, etc. Once like all these features are included, we are already feeling like we can open source it, but we need to plan accordingly. As of now, there is no road. As of now, it's not decided yet. Thanks. Any other questions? Everybody understood?
Yeah.
Okay, thank you.
When you're using this for testing, you want to read production data, you want to write in a different schema. Explain how QuickETL can do that.
That's a great question. So as you have seen, like Sandeep, in all the queries, we are not hard coding the schema names or table names. We both read and write are variables, right? So when we say that local conf, local environment conf, the write schema will be like sandbox. Even the dev or UAT is a sandbox schema. Only in prod is a, like mapped to the production one. And one more biggest advantage, like based on the query question I'm asking, this is easily can support the query virtualization. Going forward, all the companies are moving to the cloud based and where you have multiple environments altogether, right? For a given query, automatically can I submit in a dev environment, dev EMR or QA environment? It's easily we can achieve this by using this config rich environment. So that is also one more feature we can add. Any other questions? Thank you.
Thank you, Anil. Now we have a Naveen Soni, and he's going to talk about Git Sync process we had in place. Do you have the mic? Hello. Hello, everyone. My name is Naveen Soni, and I am the from Big Data Analytics Platform team. And I'm going to talk about the framework for the analytics code deployment. I hope everybody understands what I'm trying to say. So before I just go and do a deep dive, what exactly this framework does, and then how the exact this framework look like, let me quickly set up the agenda for this presentation. So I would quickly go over the traditional process and the architecture of the framework which I'm going to talk about. The challenges associated with this process which make us to move forward with the different approach, which is the enhanced serverless framework we built using the AWS services, and the benefits from this framework we got, followed by the demo and the quick comparison list, which just kind of give you an overall idea like what we gained and what we lost. Anyway, we are not going to lose anything. So let me just kind of quickly set up some a stage on this one. Let's say Gaurav, my friend, he is a emerging data analyst, and he would like to execute an ETL code pipeline into our Hadoop system, and is very enthusiastic, and then just would like to make changes and would like to see as early as possible if he can get his code executed on the Hadoop platform. And somebody told him that, hey, this is not the process you just kind of follow. You have a framework for this one. So that's how this framework looks like. So the overall idea is how quickly a person or a data analyst can get his code to the production in an exploratory environment to test it out. So the architecture looks like data analyst comes and he check out the code in the Git repo about his ETL pipeline. He made some modification, and
this wait for the scheduler engine to get kicks in, and the data gets to the jump box and readily available for the further processing on the Hadoop system. But the pain point here is that there are lots of challenges with of the scheduler engines and the agent process running on the jump box. Let me quickly go through the pain points associated with this kind of architecture when somebody is trying to achieve and wants to see their data instantly on the jump box. The jump box is nothing but a workstation or an edge node where you have your data which goes in the Hadoop system when you just execute your ETL pipelines. All right. So the process, the challenges with this architecture was if the entire process works end to end without any issues, this is still is a long time it takes to complete end to end, which is like still more than 4 minutes. So I'm just giving an example on one of the Git repo, the Git sync process. Suppose we have like hundreds of sync process running at the same times, which may clog the agent or scheduler and then made this kind of a sync issues and which causes more delay to get your code available on the agent or on the jump box. We did not have any notifications or logging in this framework or this architecture you see, whether if the user it just make any modification or pushing the code in the repo, then he doesn't have any clue whether the changes are really reached to the location. He has to log in and go all 9 yards to see that my code is already available and now I can just get on and ready to execute my code pipelines, right? That leads to the loss of the productivity for both engineers and the analyst. So support teams comes in the picture when there are these kind of issues triggers, right? They comes on our support Slack channel and then just kind of asking for help. And somebody from the support team, based on his availability, gets on the board and then just try to see where exactly the issue is. Log on the agent and then UI and then try to troubleshoot. And it's kind of lots of manual efforts involved with this approach in this architecture. So the solution and the serverless architecture we built changed the entire game. We removed the serverless dependencies. We removed the layers of dependencies on the scheduler engine. So let me quickly walk you through how exactly this solution and serverless framework we built works from end to end. You're an analyst and make the changes on the Git repo as usual you do, but behind the scene there is a webhook which is attached to the Git repo which get kicked in, which calls in an API gateway on the AWS. And this API gateway internally triggers an AWS Lambda functions. And from there, the entire magic happens on the AWS System Manager. So AWS System Manager is the location where you have all the definition of the scripts, which gets triggers on the agent, which is the jump box in my previous slides. The jump box goes and then pull the data from the Git sync. And this entire process happens very instantly. It's very quick. Just a fraction of seconds, this entire process kicks in and be completed, and then your code is readily available for further processing on the Hadoop system. Apart from that, it also sends out a notification email once you have your successful commits. Even if it's not successful, it will let you know where exactly the failure is. It also sends the Lambda logs and forwards to the Splunk for the auditing purpose. So let me quickly go through the benefits of this particular the framework. So we just cut down the processing time, which used to be like 5 minutes, to almost like 5 seconds, which I mentioned like it's very instant. We don't have any dependencies on the problematic layer where we used to have lots of issues with regards of the agents clogging, server going into the maintenance, and all those kind of issues. It also definitely it's increased the productivity because you're not engaging your support team, or you are not, as a data analyst, you are not investing your time and waiting for to see your code on in your jump box, right? It also gives a flexibility to get the notifications. You are receiving all the notification in your inbox with regards of your success and failures. And finally, let's jump on to the demo. So I'm just giving a quick example. I'm not going to touch any of the code pipeline. So I'm just trying to see this. This is one of the Git repo where we have the README file. I'm going to update these README files, and then we'll see the things in action. Go edit this file. Just simply making smaller changes. Say, commit this change. And then that's it. And I would wait here in my email to see the whether my push request is successful or not. It will take a few seconds. What's that?
Architecture for emails.
No, it's here. So as you can see, it took like maybe a 10 seconds or 15 seconds, not more than that, which I exaggerated, 5 seconds probably. As you can see in what's that? Yeah, it might be delay in the email. Thanks, Kilawa. So as you can see, it also gives a lot of information, a valuable information for anyone to understand what exactly the change is about. Subject line is very much clear. It gives you the repository information, what is the action you triggered, status successful, and if you need a further information with regards of the logs, there is a tool called Code Browser built in Intuit, which just gives you the entire information about this action, and then the successful message on the browser. Okay. So on this note, I would just go quickly cover what are the comparison from the framework we used to have and now the new framework, what we achieved. As we already saw that the time is the money here in the data business, right? So we cut down from 4-5 minutes for each request to fractions of seconds, not fraction, basically 5 or 10 seconds. There used to be lots of sync delays based on this scheduler issues or something. So we cut down the dependencies of the problematic layer in the new architecture. We used to have almost like 10 plus issues, the sync issues reported on our Slack channel. Now, since we released like 3 or 4 months ago, we have 0 issues reported so far. We did not have any of the logging notification associated with the old framework. Now have instant email notifications and loggings. And also, very main thing is the productivity, which is increasing the productivity from both sides and both parties, which is our analyst and support teams. On that note, I'll just conclude this demo. Any question and answer? Answer will be given by me. Anything? Yes. Mm-hmm.
It was a scheduler.
Yes.
That it was a scheduler, pulling the code. So is the thing that you improve, is it now is instantaneously it will pick up rather than on a schedule?
Yes.
Okay.
So schedule you can change your configuration, but on the scheduler, right? Like 5 minutes or 10 minutes or 2 minutes or something, but it will be too aggressive, right? So suppose there is a one sync process already running. You need to write an entire program to make sure that if any sync process which is already running, then it would not overlap, right? But with this architecture, you don't need to worry about, you don't need to write anything, right? It's the moment you just trigger or push your on the Git repo, right? Your code gets on the repo, the trigger which the webhook gets triggered, and then it automatically just kind of sync the code on your agent.
All right. sense.
Yeah.
Thank you, Naveen. Okay. So,
Thank you, guys.
all right. Are we excited so far? I'm pretty yes. All right, get ready. We are third person, God of Dune, and he's going to talk about dashboard as a code. Right? Welcome to Gaurav.
All right. How's everybody doing so far? Awesome. Still with me? Yes. All right. Okay. So myself, Gaurav Doon, I'm part of the Quick Data platform team here at Intuit. And today I'll be talking about a framework that we built here for creating our custom dashboards, which we call here as dashboards as code. Now, before I actually start with going into the agenda and the background for this thing, how many of you deal with dashboards on a daily basis for their jobs? Right? Okay, so then you guys will understand the problem that we faced in this journey. So before I look into give you the background or anything, I'd like to set up the agenda. First, I'll talk about the journey, the reason that we had to rethink and innovate the way we create our dashboards here at Intuit. And then I will go into the architecture that we have for this framework. And then I'll show you some of the sample dashboards that we built with some multiple monitoring tools using this framework. And in the end, it will be comparisons between what was there before and after. And I'll just end it with some of the key learnings that we learned as part of the journey. Okay, before we jump into the actual journey, this is like one of the scenarios which made us rethink how we do our dashboards. So here is a customer who comes up to a data engineer and says, I want this custom dashboard, and this should be simple enough for you to put together. I mean, it should take you like a few hours, right? You can figure this out. The engineer takes it up, but then he realizes that he actually has to put all of that raw data in multiple sources, which is not even processed and has to be put on a dashboard. Now, we didn't have any automated process to process the data or then to get it onto the actual monitoring tools. So now the engineer is thinking, hey, my deadline is almost approaching and I still have lots to do. And even if he reaches there sometimes, if somebody makes any manual change on the dashboard, then it makes him feel anxious and stressed about what am I going to do? I'm missing my deadlines. And here's your customer coming back and saying that, you know what, I want another dashboard actually. I have a need for another one. And if you cannot deliver these dashboards on time, then you are not satisfying the business need for these dashboards. So as part of this journey, we had a couple of things that were missing in the front side of it. So it used to, depending on the complexity of a custom dashboard, it used to take us like a couple of days to build it up. There was no automated way to process the raw data into proper processed data. There was no trackability for the changes that are going into the dashboard because most of the changes were done through the UI. So you cannot track what somebody is doing. And how did that make me feel as a data engineer? Anxious. If I have to present that dashboard in front of my leadership, I will be anxious to know, hey, will it even work when I reach there on the stage or not? It actually happened to us. It did not work. So that's why we had to come up with the desired state that we have here, using which we could like spin up any custom dashboards in like few hours because we have reusable code templates, a proper processing layer for the raw data, and you can have the trackability for your changes, and also you can collaborate with your team members on a dashboard. How does that make me feel? Happy. So this is the architectural flow for this framework that we have. You start out on the left-hand side of it from the data sources that we have. It could be like an analytical database like Vertica or a static CSV file. And in the end, it could be just like an Amazon RDS in which the data is sitting. So this Amazon Lambda processing layer that we built, it fetches that data and processes it in the way that we want it and stores it into stores like either an S3 bucket or DynamoDB. Depending on the type of data we have, we use different stores. Now, there is another processing layer which is running Terraform. That one has an event-based trigger. So once there is new data in any of these stores, this processing layer gets triggered and takes that semi-processed data and processes it into the form that monitoring tools like Wavefront, Grafana, or Kibana also could take. All right. Now, many of you might be thinking Terraform is mainly for infrastructure as code. And why did we choose Terraform for dashboards as code? It's actually for the for 5 reasons that I've highlighted here. First thing is it's an open source framework, and we are using these templates in our other open source projects, which are work in progress right now. One example is Cost Buddy. So we wanted to use an open source technology to automate this solution. Second part is it's a multi-provider. So it has many multi-providers like Wavefront, Grafana, and different kind of cloud providers as well. Third one is a declarative style of code, which is very important for an engineer because if you have done any kind of automation through Chef or Salt, it has to be done in a processor way. You need to know the processes and the order in which they're going to go out. Here, you don't have to worry about that. Fourth one was, which is very critical for any production dashboards, is you can have dry runs to see what are the changes that are going to go in my dashboard before even actually applying them. And the last one is the portability. So it's the same language for any kind of different providers. So once you know the language to build up your templates, you can easily build it for any of the providers. All right, so now I'm just going to show you some sample dashboards that we built. The first one is something that we built for tracking our ETL pipelines into Wavefront. Now this dashboard has both custom and static and a dynamic data. So for example, if you look at a field, something called like an ingestion leader, that's like a static data which we were pulling from the RDS. But something like the start time and the end time of a job, it changes every day. That is something that is dynamic, and based on that, we calculate whether the job missed the SLA, and if it did miss the SLA, we also set up alerts for it to go. Another example, using this serverless framework, we had this Grafana dashboard. This is actually a part of our upcoming open source project, Cost Buddy. Here you can see the cost of your different AWS resources coming based on from different accounts. So we use the same framework in this one as well. Now, some of the key learnings that we learned, and some of them we learned in a hard way, was initially building up these Terraform templates took some time and effort. But once we had it built, it was very easy to modify it to be used with different providers. Second part is, now many of you will say that in Wavefront or Grafana, I can extract or extract a dashboard in a JSON file. And then why don't you use that JSON file to make any changes or create another custom dashboard? We tried that and we got burned multiple times. Because it's a huge JSON depending on how complex your dashboard is. And if you change a very little thing, it makes a big change on the dashboard. So it was not a feasible or a scalable solution for us. Last one is more on the Terraform side, that it's kind of dependent on the providers in the sense that if an update comes, let's say on Wavefront, version upgrade or functionality upgrade, we have to wait a little because Terraform is an open source project. So until the community integrates it, we have to wait for those features. Now, just to summarize like the before and the afters. So previously, no reusable templates, could take up to days to spin up a dashboard. Now it can be up in within hours. No automated processing layer. It had to be processed manually, the data. Now it can be done automatically through the layer. There was no trackability, peer reviews, or rollback capability for the changes. We have all of them. Lack of team collaboration used to be there, but now it's not there anymore. Last but not the least is lack of dashboard as code contribution. So when we used to build dashboard, it didn't used to be counted as code contribution because you're just doing something on the UI. But now we have made it in a way that your dashboard can be as a code. And we also contributed to Terraform open source community. Now, the last thing I would like to end this thing on was, since we got so much love back from the community, we took so much from the community, we had to give something back to it. So the team made several multiple contributions, which are merged and are actually used by the community right now on one of the Terraform providers. Right, that's it. Any questions?
That you're providing the alerts. What kind of alerts you are providing?
These are like, so since the dashboarding tools that we were using like Wavefront and Grafana, so the alerts will also be integrated through those processes only. Yes, because these are metrics flowing in, these are like dynamic data, so you can set up alerts based on that.
Where are you mapping the data attributes with the UI element? For example, you mentioned it earlier, right? That's yeah, earlier you mentioned that JSON data was hard to manage because if you make some changes. So here, where are you mapping that data attributes with the UI element attributes?
Sure. So as I showed in the, I'll just go back quickly to the architecture. All right. So once we have the data to be combined from multiple sources in here, Terraform and this processing layer actually takes care of mapping it onto your UI elements. And also any kind of conditional color coding, whatever you can do with Grafana, Wavefront, those are the things maintained by this processing layer. It basically connects the data to the Wavefront UI. This is the layer. Yeah. Thank you.
Awesome. We're all dazzled by the dashboards. So we have our next speaker coming up, and actually before we do that, just a quick poll on the talks you saw. So for QuickETL, how many of you could relate with the problems that were discussed in QuickETL? Okay. For the next talk on Git Sync, how many of you guys could relate? Okay. And I think the last talk was, dashboard as code. Anything that, any takeaways in terms of relating with those problems? Fantastic. So I think this was a good session. Hopefully you guys, definitely sort of see the value, and at some point, we definitely want to give back to the community by open sourcing these projects. So, definitely sort of, keep a track of that, and we'll be hoping to leverage this. So now I want to introduce our next speaker. Our next speaker is Alejandro. And Alejandro is the CEO of MatrixDS. He's a PhD from Stanford University, where he was doing decision analysis. And this very interesting thing about something that he did there, where as a part of the dissertation, he was doing this data-driven decision support to help prostate cancer patients navigate the different treatment alternatives. Actually, when I first heard about this from Alejandro, it's very commendable. It's fantastic in terms of solving problems which truly are helping humanity. Now, ever since, Alejandro has a startup that he's co-created with Isaac, and it's something that is very interesting as a data science platform. Things which is actually being used in a few places. So without further ado, I want to call in Alejandro, and we'll have the next half an hour that we'll cover this talk. Thank you.
Headless mic?
Sure.
Okay. I guess that's working. All right. Let's see. All right, I was just debugging a second ago what I'm going to show you, so. No. Mirror displays.
He has to join the blue jeans.
Ah.
Can we connect him directly?
Blue Jeans the quickest?
I think that would be easy. If you go to bluejeans.com, flash that number on the screen.
Number of engineers it takes to.
Slash what?
That number, I'll read it for you. 312-804-7860.
7860. Oh, I have to download it. Perfect.
Time to take a break, guys.
Sorry about that. There it is, right here. Got it. I guess. Are you're gonna record my computer screen?
No.
And I'm just gonna. Meeting ID again. Okay, so 312.
312-804-7860. 7860.
Oh, I went to the link and it has me input it in the actual app. It looks like I'm on. All right. Jeez. Apps ability to record content on your screen while later. Okay. Click here to start sharing. All right. Sorry about that. So I want to tell you a little bit about what we've created when we set out to do Matrix DS and how this whole story started. Sorry. So Isaac and I met while we were doing our PhDs at Stanford, and we were trying to do some data consulting, data work for different people. A lot of it in healthcare, some of it in energy, some of it in other industries. And I distinctly remember one day, and I'm going to show you sort of a caricature of that day. And I'm sure all of you have gone through this at one point in your life. So there's a problem that we're trying to solve, and there's 3 of us working on it. And to do data science in any significant way, you need at least 4 things. data, code, infrastructure, and some apps, whatever those apps are. And so the way the process works is usually you go from very big data to smaller data, which makes your models bigger, you need more resources, and then you jingle them all together to produce some output. And then if you're not sitting in the same room as that other person and you're stuck somewhere and you want to collaborate, or you want to send it over to a decision maker, or you want to send it over to somebody else, you want to share it, you want to publish it, that becomes super painful. So the way we do this is I'm going to upload this data to an S3 bucket somewhere over there. And then I'm going to give you a GitHub repo with all of my stuff. And then I'm going to give you a README file so you're sure how to install all of these dependencies and all of the packages that you're going to need. And so that replicates the process for everyone. And then everybody has a local version of it somewhere, and you're all working on it. And this problem escalates very, very far, very, very easily. And if you did a particular subset of the data and you're stuck and you want me to do it, to see it and to help you, then this process becomes very, very painful. And so what we said was, well, there has to be a better way. There has to be a more interesting approach. And what we came up with was, well, what if we are on a network file store that shares apps, shares code, and shares infrastructure for each person on demand as they need it at every moment. And that's sort of what we've created. That's sort of the baseline for how the platform came to being. And what that means is when a person leaves the team, it's very easy. You can just plug the next person in and everything works seamlessly all together. And then when new apps come around, like whatever, you just install them at the top, at the global repository, makes them immediately available to everyone at the same time. And then when something is produced, whether it's a report or an API or something that we want to share out to the world of non-developers or people not creating the content, then we can make that secure connection very easily so that that person can just consume from the finished output without having to go through the entire pipeline. And so that's the product in a nutshell. That's what we've tried to build. This is the problem we were trying to solve. And so we call it the ultimate data science development platform. And the reason we're different to many other people making claims like this is if you think about the basic data science process, which is something pretty much no one can agree on, but this is our version of it. To us, it always starts with a business question and it always ends with a deployed solution, whatever that solution is, API, dashboard, model. And in the process, you munge, model, and visualize till you create something. And a lot of times you iterate and go back because whatever you did in this process teaches you something that makes you go back and change. There's fantastic tools out there to help you munge better, to help you build better models, to do version control of your data, to do version control of your models, to visualize. But what a lot of people are missing is that the handoffs between these processes is what makes it hard. It's moving from one step to the other. And so we built MatrixDS to sort of be an overarching layer that sits on top that lets you use anything that you want, fully flexible, and does not compete or does not forbid you from using these other tools that you're used to loving and to coding in and to building in. And what we do is we're an orchestration layer at the top that abstracts away all of this passing along of things as you move through this pipeline and through this process. So having said that, let me show you. By the way, this is the free version of MatrixDS, which you can get to by going to www.matrixds.com. When you first log in, this is what you see. You're going to see a bunch of projects. These are my most used or my most recently used, and all of my projects are here. We've built the UI to have a look and feel very similar to GitHub. And so what I want to do here is I have a demo lined up with a project already existing, but I want to walk you through what a new project would look like if you were to start something. We're just going to go ahead and create a project called Democratize Data. And I don't know what's happening. There we go. And so it's empty right now. Every project has, many things that you can do with it. Right now, there's nothing in here. What I'm going to do is I'm going to create a tool here to start working on it. So there's different flavors of tools that come available out of the box on MatrixDS. All of them are open source tools. Because we're built on top of a Kubernetes engine and Docker infrastructure, we can actually use any tool that can be containerized very easily on MatrixDS. But off the box, we only give you open source ones for obvious reasons. So you can see here we have, Julia, Octave, Python 2, Python 3, Jupyter Notebooks and Jupyter Lab, R with our studio or without it, and we have a tensor board in there. These are munging modeling tools. As far as present tools go, we have Boca-Flask, sort of fully committed to the whole Python stack, and then Plumber Shiny if you're on an R stack, an Nginx container in case you want to do something on a straight up website, and Superset, for those of you who are not familiar, it's an open source version of Tableau Apache project. We also support databases, so storing tools. These are not meant to be data lakes. We're not meant to substitute your official data store. This is meant to be for modeling purposes. I'm scraping unstructured data. I want to store it in a Mongo or in a MySQL database temporarily while I build my model, and I want to have it here. The databases created inside MatrixDS are only accessible from within the project. There's no other way to get to them. They live inside the containers. And then because we're built on top of Docker, we're super Docker friendly, which means any custom image that you guys have created, if you host it on Docker Hub and just paste the image name in there, you can just launch it against any size backend that you want. And so what we do with these tools is we make it very easy to spin up and down anything that you need in a particular moment in time to build something. And so let's say we're building a Python model and I like Jupyter Labs, and I say, well, I need, I'm going to try this with 4 cores and 26 gigs. So what that does is it provisions that much compute resources in the cloud and mounts the file store for this project and this project only. So every project is a network file store that's accessible to everyone inside the project, and then mounts that as the local directory to this Docker container that has this much backend in the cloud. And you see it took a couple of seconds, and just like that, with no installation, no nothing required, I'm running my Jupyter Lab with that resource already provisioned behind it against this particular project. Now, this is an empty project, so it's not that much fun, but I want to show you on a non-empty project. So one of the things that you can do on MatrixDS is we wanted to build this in a way that allowed people to showcase their talent, what they're doing, and so you can publish your entire project, whatever that is. And published projects can be forked. And when you fork a published project, you not just get the code, you get the dependencies, you get everything, all the environment descriptors of that particular project. We don't create the environments for you. You have to go do that manually yourself. But when you do create a Python environment in a Python project, you will see exactly what that person left for you to see immediately. So you'll see if they loaded a variable into memory, you'll see a variable loaded into memory. The environment transitions itself completely, because the way that we've built the architecture of MatrixDS is that everything that belongs to the environments gets saved to that network file store. And as you fork it, you take with it everything. So all the dependencies, all the packages, everything. So let me show you. This is a public project that we have. It's called MatrixDS Demo Project, and I made a copy of it for this particular, I've already forked it for this particular presentation today. But you can find the published version of this project in our website. If you just scroll down where it says, grab one of our starter projects, this is our demo project. And the reason I picked this one is it has a little bit of everything. It has some R code, it has some Python code, and it has a deep learning example, which I was debugging until a minute ago. So let's go and show you what that looks like. So you're inside this project. You can see there's a bunch of files in it. These are just the most revised files right now, so it's not in the official file structure. There's a description of what this project is. So if you're an R user, there's all this stuff in here. If you're a Python user, there's all this other stuff. If you like web dashboards as well. And then there's a lot of interesting things built in this project. You can immediately see I have 3 pieces of infrastructure running against it. I have an RStudio tool, I have a Python 3 tool, and I have a Shiny tool. So I'm going to go and open the Python 3 tool, which I actually have it open right here. And so you can see I am mounted to this network file store that has, data science with Python, data science with R, deep learning demo, folder called HTML, folder called logs, and Shiny server folder. If I open the RStudio tool on that same project, you'll see it's mounted to the exact same directory. So what this means is sharing across tools inside a project is extremely easy because everything that gets saved gets transpassed to the other person immediately. And And so I've opened this deep learning example with TensorFlow, which please don't judge me on its accuracy because it's not very good. But essentially trying to predict the number on your hand. And I trained it for 1,000 epochs. And this is my accuracy right now. And this was a test against an image that I uploaded. And the algorithm predicted 3. So the other cool thing in this project is that within our studio, we created a Shiny tool. For those of you not familiar with our Shiny, Shiny is a way to create great lightweight web apps or dashboards all in our code. And let me get rid of, there we go. And so when I open the Shiny tool, this is what you see. It's a upload app. So let me show you first how easy it is. This is already in production. One of the interesting things that the Shiny tool has is that it can be made public, which means the URL for that app is available to anyone, regardless of whether or not they're a MatrixDS user. So just completely published out into the world. And so this app right now is live, and I'm going to show you how easy it is to modify it. So inside, you can see right now it says John demo, because John was the last person who saw a demo. And if I just, okay, just look for that. There we go. If we just change this to democratized data and just click refresh, the whole piping is done, so it works with continuous deployment. Every time you save something into the Shiny container, it immediately updates what's live. And the beauty of this being public is that I actually have the URL here. And I can take a picture of any one of your hands and get it immediately uploaded into that deep learning demo. So that's what I'm going to attempt to do. Let's see. I'm just going to go ahead and take a picture of someone's hand. So there we go. You are the guinea pig. All right. So pick however many you want. Try not to get the cables underneath.
Your engagement ring.
Too shiny.
All right. And so let's see. I'm going to call this image with your name. What's your name? GD. Perfect. GD. And photo library, load this image. So I don't know how you can see there, but yeah. And I've called the GD, and it's uploading. Oh, there we go. I was going to say I'm not connected to the Wi-Fi, so this may be a little slower depending on my signal. Your photo is uploaded. All right, so now I'm going to go back to Jupyter Lab, and I'm going to go into the deep learning demo images, and we've got gd.jpg right here. Very large image, but there you go. Yeah. And so I'm going to go back to my script here and just say, well, now I want you to use gd.jpg and run this again. And you can see my prediction is terrible because it predicted 4. But it is the right image, and it is a way to integrate something built in different technologies being used by a phone without having logged into the platform to upload into a deep learning model. And so think about what you could do with something like this. The other feature that I want to show you today is this thing we call jobs, which is essentially, I've already done this, and now I just have this script that's going to train this thing. And I want to do this every month because I'm going to be scraping some data, and I'm going to have a new test set every month. And so this is just a cron job scheduler for Python and R right now, and coming soon, a lot more stuff. But you can just say, Python 3, and this is essentially a command line. So I would just say Python 3, myscript.py, and I can say run this later, do it tomorrow at midnight, repeat it every day, and it's going to need, 8 cores and 64 gigs of memory. And when I click create, right now it's going to fail because that script doesn't exist, but then it schedules this job for every day at midnight to run and update something. And so the way all of these containers, the percent containers work, whether it's an API or a dashboard or, or a Shiny app or an Nginx, is they create their own folders inside MatrixDS. So if we go back, I'm going to do this from within a tool. So if we go back to the file structure that we're mounted on, anything inside the Shiny server gets immediately mounted into the Shiny container. Everything inside the HTML server folder gets immediately mounted into the Nginx container. So let me show you how that works. What we did with the HTML container here is I literally downloaded a GitHub repo and just threw it in that folder. It's a Keen.io dashboards repo. And so I'm going to go ahead and create, oh, sorry, wrong place. An Nginx container, just a basic one. If you don't have that folder created, MatrixDS will create the HTML folder and serve you our template HTML or our template Shiny or our template API, whatever it is, and then you can just modify it to have whatever you want. But I'm just going to open this, and you're going to see this is a fully hosted version of Keen.io dashboards just from their GitHub page that I just literally went into the terminal and did a git pull. And you can open it up. And all of these dashboards are live and working. Not necessarily live because I don't think they update, but work. Page views by browser. I'm pretty sure this is a fake dashboard because I can see Dunder Mifflin in there. But yeah, you can see a fully deployed web page off of MatrixDS. So if what you're serving to your decision maker is you want to serve it in full HTML style, then you can use a static web server. If you want to serve it with Boca, which is a sort of a Shiny equivalent for Python, that works as well. If you just want to do a dash, that's fine too, or a Shiny. And then we also support Flask and Plumber in the same way. The way the APIs work is the URL is where you call. So you just ping that and it'll return whatever you've programmed it to return. And so you've all seen this on the free tier of MatrixDS, and we also offer an enterprise tier to help, teams inside corporations move much faster in their data processing and in their data publishing and deployment. So that's MatrixDS in a nutshell. I'm not sure if I'm out of time. Okay, so if there are any questions, this would be the perfect time. Oh, sorry.
What kind of cloud service are you working on? Because I see you allocating 4 cores and 26 gigs.
So we're in a Kubernetes engine in Google Cloud right now. So our backend is all GCP. The reason for that was when we started a couple of years ago, GCP had the best support for Kubernetes. Amazon was just starting, and it made a ton more sense for us to go native since Kubernetes is a Google project. But today the product is built in a way that it can be deployed on any Kubernetes engine on any cloud provider. So I think Amazon now has AK, whatever. I don't know what the acronym is, but you can deploy it on AWS on a VPC, or if you have a Kubernetes engine on your on-prem servers, we could deploy it there as well. But yes, the way we offer it to people, I say, well, unless you have a really good reason, it's easier for me to be your cloud provider than for you to plug me into your other cloud provider. And when that happens, it's all GCP backend. You had a question? Over here.
So you were talking about sharing like data science models between people, right?
Yes.
So I'm curious as to how is there a way for me to share my trained model with another person who starts off from there and
Yes.
like.
So this is the project that you have right here. You can see Isaac, my co-founder, is in the project as well as a viewer. Oh no, as an editor, sorry. And I can add anyone's email address here, and that invites them to the project. If they're already a MatrixJS user, then it immediately adds them to their project page. Otherwise, it has people sign up for a free account. And that means anybody can see this exact same Jupyter instance as you left it, or R instance, or whatever it is. And it makes it super easy to collaborate. There is one problem right now, the way it's built. If you're both in the same file at the same time, it's not recommended. We're actually building one of our features on the feature backlog is we're building a deeper Git integration. So right now there is some Git integration. Let me show you. So the way it works right now is we are running our own internal Git client, and we do a Git commit every time you save. Every time you hit save on a file, there's an automatic Git commit event happening. And so here, for example, if you go to this .text file, you'll see every previous version that was automatic commit. And you can just revert to them and say, you know, what did this look like back then? Oh, I'm not sure what happened there. But you can revert, you can see any previous version and then ask to revert to that version or save that version as the current version. So if you wanted to see back changes, but the way what we want to build to it is a much deeper Git integration where the published project or the official project is working off of a master branch, and then as you code, you're updating your local version of that branch, and you have to force a Git push every time you want that to update to the master. That's not there yet. It's coming.
One question is, so you are internally building the Kubernetes framework internally, but when you are launching any kind of different applications, front end to back end, and it's completely in Docker composed YAML, and it's trying to one container, it is linking to other container. So in UI itself, everything is linked together right now, or you created one app right now, right? So like that, so the front end, back end, and everything you're linking together from UI itself, everything, or you need to do customizations?
No, so everything is linked from the get-go. The way the containers get mounted and launched is sort of our secret sauce. We just let you create containers, whatever you want them to do, and launch them on us. But we take care of those connections. And so, for example, on an enterprise account, somebody says, I'd like this non-open source tool there. And so we figure out what's the best way to containerize it. If it's not containerized already, usually what I say to people is it has to have a server-based app, because otherwise, I can't containerize everything.
If you want to customize everything, every time we need to come to you guys, actually?
No. So if you're customizing, if you're changing, so all of our containers, the containers themselves are open source, and you can go to our GitHub repo and see our Python container, our containers, our Shinies, Nginx, everything. And so you can modify those and reuse them immediately. It would be if you wanted something very specific and you can't get it working immediately. So usually we have pretty good documentation on how to do everything with custom containers. But if you get stuck, then we're there to help you figure it out.
We will provide you our own VPC and everything internally, and on that for security purpose, I'm asking. So everybody can access it, right? So you will be providing some kind of security also.
So if we're in your own VPC, then the security is all yours. Okay. Because we don't take, I don't mess with your VPC.
For the folks who are on your cloud using this service, right? How do you allow them to connect to their own data sources? Like as part of the data merging, like it would be extremely important.
Absolutely. So there's one way right now, and we're working on a simpler UX way. Every container is internet enabled. So if you know how to connect to an S3, to a Redshift, to whatever, I give you a terminal inside RStudio or Jupyter or whatever, and you can just connect to it. You just have to know how to do it right now. What we're working on is building sort of a UX like Tableau has, where I can say, is it Redshift? Write your SQL query here. Mm-hmm. Is it whatever, and that starts importing stuff into our the network file store that Matrix runs off of. And so that's not there yet. That's a feature that's coming.
So are you expecting them to open up the connections from your IPs, stuff like that?
So the way we do it right now is we figure out how to best connect within your internal security practices and what is the right way to do it and what can we do when you connect. And we do this very closely together with the internal IT teams on different organizations. We have not yet deployed on anybody huge. We've done it mostly in medium-sized companies where there's less concerns like that. And so essentially they just open up a couple of ports for us to plug into something. But yeah, that's the way it's happening right now.
Hey, so if I chose like configuration of like a really large machine,
yeah.
So who gets billed first, right? Do you get billed first and then you bill the customers, or like?
Yes.
The
So
billing goes straight seamlessly to the customer.
I become your cloud provider in that case. So if I'm hosting, I become your cloud provider, and you get a monthly bill that says you consume this much. This is what it costs, and my cost is all passed through whatever Google charges for dedicated VMs. So I think it's something like 3 cents a core and 0.3 cents a gig of RAM, and then an hour, and then 3 cents a gig of store a month.
So do you charge a premium on top of what Google charges, like for the hardware, or?
So I charge VM prices. We get some efficiency because we're a Kubernetes engine, and so we can distribute the load on our back end and make some profit on the margin. But to the end user, you get charged what you would have gotten charged if you had gone straight up to Google and said, give me a VM.
So I think nice demo. When you compare the data science platform, right, the end-to-end, how would you compare it with projects such as TensorFlow Extended or MLflow or things that are going on in this space?
So I think, yeah, that's a great question. There's a ton of people in this space. I think the difference is they're focused on very specific pieces. So they're focused on how do I get your models built and deployed, but not necessarily looking at what was the ETL like to get into it, what did I load, what did I transform, and how did I use that to train the model, and then where does that model get embedded in? So we wanted to go full end-to-end stack. I think there's for sure one other company doing this. It's called Domino Data Labs, and they're one of our biggest competitors. Very different approach, them and us. We are, well, if you ask me, way easier to use, way nicer UX. And I think we're a lot more flexible. Domino only lets you use the containers that they've built. I don't even know if they're containers or how they're actually doing this on the back end, but they only let you use the stuff that they've pre-cooked. We want it to be more in sync with the open source community and saying, well, you want to do what you want to do. And all of you probably have modified versions of Jupyter that you're using commonly because it has certain dependencies that you've pre-built for the particular tasks that you are doing. And so we wanted to empower people to have that and to be able to share those exact environments and not have to recreate them every time. And so we do this all the time. I just had an implementation with a customer who has a very convoluted Shiny app that calls a ton of Python scripts to do heavy math solving of differential equations. And we had to create a specific container for them that had a Shiny container that had all bunch of Python libraries that you wouldn't normally find in a traditional Shiny app because they needed the full integration between them. And so all of these things are possible if you know how to containerize deploy. And if you don't, you can call us and we can do it for you.
I think makes sense. If you look at like companies, right, everyone is kind of building their equivalent. You have FP Learner from Facebook, Mishlango from Uber, and so on. So definitely, I think what you're trying to do is more generalize in some sense and make it much more flexible. Is that how you're approaching? Is that the design principle?
Absolutely. And because all the containers are internet enabled, and you can install a bunch of these products just from the command line. So things like Comet ML, or I actually haven't tried MLflow, but I'm sure I can just pip install MLflow or sudo install MLflow into a MatrixDS container and just use it from there. So we don't want to compete with these people. These are great products. We're not in that business. We're just helping you orchestrate at the very top layer. That's our business model. That's what we want to do. So when I first met Sandeep, the title for this meetup really resonated with me because our entire mission was to say, well, how do we get more people working on data science without having to know everything? How do we democratize it? And the whole process started as Isaac and I were doing a project for USC Medical Center. We were trying to help them figure out for a patient on dialysis who's waiting for a kidney, should they accept the kidney offer that's on the table right now that UNO's just provided, or should they wait for the next one? So if you think about this problem, this is essentially understanding what the rate of arrival of the next kidney is. Because not all kidneys are made equal. Some are lower quality, some are better quality when you're receiving donors from deceased people. And so I've received a kidney that is, let's call it medium low tier quality. And if my rate of arrival for a better one is tomorrow afternoon, I might pass on this one and get the next one. If my next rate of arrival is in 7 years, I'll probably take this one. And so as we were building this product, this analysis for them, neither of us was trained as a software developer, as a software engineer. So DevOps was sort of our kryptonite. How do we get through these things? And it was very painful. And we just went down to the drawing board and said, what would need to exist for us to do this seamlessly as statisticians and engineers that we are? And how do we build that? And this is the end product.
Whatever the containers and everything. So you have any kind of dashboards. This container is live, whether it is auto-scaled and all those things. Actually.
So right now they're not auto-scalable. That's another feature that's on the backlog, particularly for present tools. So if you have a Shiny, if you have an Nginx, if you have an API, you want it to auto-scale based on demand. That's something that we want to build, and it's in our feature backlog. We don't provide nice monitoring. We just give you access to the logs of every single container. So you can just, there's a folder called logs in here that has all the logs for every container and every tool in it. And you can just go in and see. And oh, by the way, the easiest way to get there is to say, you go back to tools. I don't know why this is slow now. Every tool has like a 3-dot button that opens another menu, and you can just go straight to the logs from there. Right here.
I know we are over time. I know Alejandro would be here, so maybe keep the questions coming for a few more minutes. Really want to thank everyone. So absolutely, hopefully this was fun, useful, and we plan to continue this on a monthly basis. Obviously, with December coming in, we're taking a break. We'll restart in January. So with that, let's thank the speaker again, and please bring the question.
Thank you.